Hello there, Science Fam! Today, we're diving into fascinating world of gases Boyle's law. This law helps us understand how gases behave under pressure. It was discovered by clever scientist named Robert Boyle in way back 17th century. Pretty cool, right?
Boyle's law is all about the relationship between the pressure and volume of a gas. This tells us that the temperature stays the same and the pressure of the gas increases as his volume decreases, and guess what? It works the other way around too. When the volume increases, the pressure decreases. This law is so important because it helps us to understand how gases works in so many situations. From inflating tire, scuba diving, Boyle's law is everywhere.
So buckle up and get ready to a fun ride as we explore the in and out of Boyle's law together. Imagine a group of energetic gas molecules bouncing around inside a container. These molecules are constantly on the move, colliding with each other and the container walls. These collisions create pressure. Now, let's say pushing the container size while keeping the same number of gas molecules have less space to move around, so they bump into each other and the walls more often. This increased bumping means high pressure, and the flip side. If we make the container larger, the gas molecules have more room to roam. They collide less frequently, resulting in lower pressure. It's like a dance floor. The more crowded it gets, the more likely you are to bump into someone. This inverse relationship between pressure and volume is at the heart of Boyle's law.
Remember, this relationship holds true only when the temperature of the gas remains constant. Let's visualize Boyle's law in action with a simple example. A gas container with a movable piston. So imagine a cylinder with a piston that can move up and down, trapping a fixed amount of gas inside when the piston is high.
The gas have plenty of space to spread out. This means that the volume is large and the pressure is low. The gas molecules are chilling out, enjoying the spacious room. Now, let's push the piston down, compressing the gas into a smaller volume. As we push, we're giving those gas molecules less and less space to bounce around. And what would actually happen is that the pressure inside the container increases.
Section 4. The formula putting Boyle's law into action. Boyle's law isn't just a cool concept, it's a mathematical relationship that we can express with a simple formula: P1 V1 equals P2 V2. Don't let the symbols scare you. It's easier than it looks. Here's the breakdown. P1 represents the initial pressure of the gas. V1 represents the initial volume of the gas. P2 represents the final pressure of the gas. V2 represents the final volume of the gas. This formula tells us that the product of the initial pressure and volume of a gas is equal to the product of its final pressure and volume as long as the temperature stays the same. This formula is super handy for predicting how changes in pressure and volume will affect a gas. Example, if we know the initial pressure volume and the new volume of a gas, we can easily calculate its new pressure using Boyle's law.
Section 5. Real-world boils from syringes to scuba diving, and Boyle's law is more than just a scientific theory. It is a principle that pops up in countless real-world applications. Think about the syringe. When you pull back the plunger, you are increasing the volume inside the syringe, which decreases the air pressure. This lower pressure allows the liquid to get sucked up into the syringe. Or consider scuba diving. As divers descend deeper into the water, the pressure surrounding them increases. This increased pressure compresses the air in their lungs and diving equipment. Boyle's law helps divers understand and how this pressure change affect their bodies and equipment. These are just a couple of examples of how Boyle's law is at play all around us. It's a fundamental principle that helps us understand and navigate the world of gases.